For this next question, we need to show that for this function here, this function y minus 5x plus 2, we need to show that it is decreasing for all values of x. So decreasing is a term that's used to describe the function, and the way we can test that is to use the gradient. So the first thing I need to do is find the derivative, and that is just going to be minus 5. What this is telling us is that the gradient of this function is always minus 5. That is, it is always negative, and that's regardless of any value of x. There's no x in here. So that's all we need to do for this particular question. The next one is quite similar. We need to show that this function is always increasing for all values of x. So again, I find the derivative and I get 1. This tells me that the gradient is always positive, because that's a value of positive 1. In fact, it's always 1. Therefore, the function is increasing. And again, that's for all x, because this was independent of x. There's no x in that function. It was just always positive 1. The next question is very similar again. We need to show that for this function, we need it's increasing for all x apart from at one place where it's stationary. So we'll do that. First, starting to find the gradient function, which is the derivative. I use the power rule and I get 3x squared. Now, it says show that it's increasing for all x. So now we need to look at x here and consider what happens. And we look at it for a couple of different points. We consider that where x is positive, and if x is positive, then y dash will be 3 times some positive number squared. Well, that's going to be 3 times a positive number, because a positive times a positive is still positive. This is positive as well, so the answer here says that the derivative is positive, therefore function is increasing. Now that's just looking at the positive case. We now need to look at where x could be less than 0, and we see here that y dash would then equal 3 times a negative number squared. Well, a negative number squared is going to be a positive number, and again we end up with a positive answer. So therefore the function here is also increasing. We need to show particularly what happens at x equals to 0. Then I would have y dash equals 3 times 0, which is actually 0. Because the derivative is 0, what we have here is a stationary point. It's not increasing, it's not decreasing, it's stationary. What that means is at that point the tangent is horizontal. The next question is quite similar as well. We need to show different cases for positive, negative and 0. So the first thing I need to do is find the derivative. I'll use the power rule. I'll get 6x. I'm going to consider first where x is positive. Then the y dash would be 6 times a positive number, which is positive. So therefore it's increasing. That was our first section. We consider where x is less than 0. Then we get the y dash is equal to 6 times a negative number, which is negative. So in this place it is decreasing. Then we look at x equals to 0, because it's at x equals 0 it's not positive and it's not negative. So we have to look at that case separately. And we get that y dash equals 6 times 0, which is of course 0. So therefore it's a stationary point at this point. Furthermore, we can see that because it's increasing on one side and decreasing on the other, this is actually a turning point. At this point. Okay, we've just got 2 more in this little set to go. The next one says to show that for this function it is increasing for all values of x. This is question 2. So this means that I firstly need to convert this to a power, so that's x to the half. So we know that the square root means power half. then I can use the power rule to find the derivative, which gives me half x to the minus a half. It might help me if I convert this back now to the third form, and what I'll get is 1 over 2 times the square root of x. X to the half means the square root of x, the negative means on the bottom of the fraction here. Now I need to consider the values of x. So what I'm going to do is I'm going to look at the three cases again. I'm going to look at where it's positive, where it's negative, and where it equals 0. So let's have a look at this first. For x positive, I'm going to have 1 divided by 2 times a positive number. I don't know what this is. It may be irrational because I'm going to take the square root of a number, but if that number is positive, I can take the square root of it. So basically what I've got here is 1 divided by a positive number, which I know is going to be in positive, therefore the function is increasing in this section. I've just checked the question again. It's actually for x less than 0. Sorry about that, but that means we don't need to consider these two. I'll briefly mention why we won't, because if x is less than 0 here, then what we're going to have is a negative number inside our square root function, which we actually can't do in our real number system. So this would not exist. In fact, it doesn't exist in the domain of our function. Similarly, at x equals to 0, whilst we can take the square root of 0 and it would be 0, the function would exist at that point. The derivative does not, because we can't have 1 divided by a 0. So we won't consider either of those. I had incorrectly written the question, so that's all we need to do for that particular one. And the last one here for question 2 is question 2f. We need to show these two cases. So again, I'm going to just convert this very quickly to a power. So it's x to the minus 2, so that's y. Then I'm going to do the derivative, is minus 2x to the minus 3. And it will help me if I convert this back just to an indice so I can consider the cases. So I'm going to consider here where x is negative, x is positive. It doesn't actually say to do that, but we'll also look at the x equals 0 case to see what's happening there. Okay, for x equals negative, a number, we've got y dash is minus 2 divided by a negative number cubed. This bottom piece here, what this means is we've got a negative times a negative times a negative. 3 negatives multiplied together will be negative. So the next line will say negative 2 divided by some negative number. A negative divided by the negative will actually be a positive answer. So therefore, in this place, our function is increasing. So increasing for x less than 0. That's what we've just shown. Let's have a look now at x greater than 0. So I start off with the derivative again. Divide that by a positive number cubed. Now this means we've got a positive times a positive times a positive. It's all going to be positive. So when we rewrite the gradient function, we've got negative 2 divided by some positive number, and that means we're going to have a negative result. So therefore the function is decreasing here. And that's what we had to show here. Now whilst the question doesn't ask for it, I said I wouldn't have a quick look at what's happening at this particular point. We've only looked at either side. When we look at this function here, we can see that if x was equal to 0, we would have an undefined function. There's actually an asymptote at this particular point. As the function is undefined here, we'll also find that the derivative is undefined here because we've got minus 2 divided by 0. So we just say it's undefined. It doesn't actually exist here, but we would know from our knowledge of hyperbolas and rational functions that we're going to have an asymptote at this point.